Welcome to Spring LIB.
Hello. In the question we have given that as a physical therapist, you are advising a patient with tendonitis in her elbow who asks she if she can pick her beloved miniature. So it is a toy. So the mass of toy is given to be 6 kg. Further, including his leather police uniform and associated bling. So you advise her arm should not support more than half that. So means whatever the weight we will find, so she cannot support more than half of it. So half of it she can support, and she asks walking with him around her neighborhood. He may pull but won't bolt. The sidewalk is the flat level, so the coefficient of sliding friction and this is given. So we will see what we have to do is, so weight of toy will be m times g. So mass is 6 into 9.81. So this gives us the answer as 58.86 newtons. So this is the weight, but now only half of the force she can apply. So the maximum force, therefore the maximum force that can be applied that can be applied by her is half of weight of this toy, that is this. So we can say that then this force turns out to be 29.43 newtons. Further, now it is given that the coefficient of static friction. Now whether this force which is applied, is this force able to move move the toy or not, that is what we have to see. So the friction force we can find by using F is equals to mu times mg. So mu is given, that is 0.45 times this 58.86. So from here this force turns out to be 26.48 newtons. Now we can note that the force applied by her is greater than, so let's say the force applied by her is greater than the friction force, and that is why the patient can walk with the toy keeping the leash horizontal. So therefore the patient can walk, she can walk with toy keeping the leash horizontal. Now the second part is, this leash is at an angle of 30 degrees. So if the leash is at an angle of 30 degrees, so we will resolve the components. So the component, the normal will be, so normal will be equal to this weight mg minus f sine 30. So from here so this is the normal force. So if we plug the value, if we just plug the value, so this becomes n is equals to mg is 58.86 minus f sine 30. So this is the vertical force Now horizontal is F cos 30. Horizontal force is F cosine of 30. Now since now we want the minimum force, so net force acting on the horizontal should be equal to 0. So what we can do is we can equate, so F cos 30 will be equal to mu times mg. So this is the force in applied in the forward direction, and then there will be a backward force, that is the friction force, that is F. So this will be F cos 30 is equal to mu times n, because if we draw the free body diagram, so according to the free body diagram, this is F. So this component will be F cos 30, this component will be F sin 30. This is what we are doing. This is normal and this is mg, and then there will be a friction force over here. So in the horizontal we have F cos 30 minus F is equal to 0. So we are equating this just. So this will be F cos 30 is equal to mu times n. N we just calculated, it is mg, that is 58. So it is 58.86 minus F sin 30. So if we plug the value, so it will be F cos 30 is equal to mu is 0.45 into 58.86 minus F sin 30, and if we calculate this, so we will get this force as equal to 24.27 newtons. Now this force is greater than, so this value of F is less than the maximum force which the patient can exert. So that is why at this position also she can walk with the toy. I hope you find the solution useful. Thank you.